Hey guys, welcome to lecture number 13 of my AI agents playlist. Guys, this playlist is going very nicely. And today guys, we'll be covering a very interesting topic, and this topic is super interesting in terms of all terms. So first of all guys, let's just talk about basic idea, right? So whenever you're creating, let's just start by talking about basic idea and what today I'll be telling you. So guys, the main theme that we'll be covering in today's lecture is agentic memory. So it's an introduction to agentic memory, and mostly guys, I'll be also talking about effective memory as well. So this is a very important lecture, as in when you're trying to create any chatbot or any agent. So guys, why we are even making this video, right? The first idea is that what is the first idea is that you need to understand that an agent needs to know you. So this is the first idea, right? So essentially, let's just go to chat gpt. Let's just go to chat gpt and ask it. So it as in when it's sort of a new session gets created, right? This is a separate chat, right? Tell me about myself. If I'm going to ask itself, tell me about myself. Now now see what it is asking, right? See, how does it know all this part? It is a new session. In an ideal setting, in most of the chatbots that you would have used across, let's say, your organizations, or for that matter, let's say any chatbot, right? Amazon chatbot or anything on those lines, right? Any chatbot which you have used, they would just start a session and everything would be up fresh, right? It's more like you are meeting a new person every time. It's going to know very well that what we are talking right now, because that's what we've been doing, but it doesn't know me, like what have been my past behavior, what do I do, and like what stuff I like to discuss, and that's pretty much it, right? And that's what we are going to be implementing today in a very, like a very basic and rudimentary way, but this is going to be an important foundation, because once you have the foundation, you can start experimenting these things in a real time product. So just try to imagine guys how it was able to answer it, right? That means for some people it is some sort of magic that is happening, but trust me guys, this is very simple if you understand a bit from the back end things, and we'll make it understandable from the back end in a very simple fashion. So don't worry, right? This is not a magic feature. OpenAI has so many magic features, but this is probably just a smart way. But let's just try to understand that why we are talking about it, because we need to have a memory, right? So agent needs to know you. Agent needs to have access to my 100,000 conversations which I have had with it, and then it can probably understand me a little better. And once it starts understanding me a little better, it can recommend me stuff which is very nice, right? The recommendation system would improve in general as well, right? The response mechanism over time improves, right? Let's say you meet a person on day one, your vibe doesn't match, but you keep on trying. So over, let's say, 1,000 conversations, your vibe would match, right? Both of you would understand each other's limitations, and pretty much the same is going to happen here as well. Now this is the main idea guys. Agent needs to just improve with every conversation, right? Every conversation I'm having with an agent, it needs to improve, right? So that is why we are making this lecture. So the first thing is, so let's just look at basic chatbot, right? I'll be telling you about memory techniques, but let's just look at a basic chatbot. So let's just go to Python, and let's just look to a basic chatbot. So this is a basic chatbot guys, a simple while loop. Okay, it's gonna simply just call an LLM dot invoke messages. So what is messages? Messages is just a list that I have created from three things: system message, human message, and AI message. That's pretty much it guys. It's just gonna keep on iterating, right? It's just gonna keep on iterating. That what is going to happen is that as and when something is happening, it's just keep on going to iterate, right? It's just keep on appending whatever messages is coming, right? So what is the user message, it will append to the list, and what is the AI message, it will append to the list, and then we are using invoke method on that thing. Very simple, guys. This is what most kind of chatbots in the world that exist today are at it. Obviously OpenAI is a step, not a step, I think they are probably half a decade ahead than most of the tech companies, so that needs to be there, like in terms of core development, right? In terms of tech development, obviously in IP they are maybe 100 years ahead, but in terms of core tech abilities they are like half a decade ahead. So that is probably okay, but still you are able to see most of the companies implement chatbots in this way. This is very simple, right? We have been doing this LLM line all our lectures. It's been lecture number 13. So today I'm finally going to skip this. It's just you need to set up your LLM via LangChain. We are using Gemini, and we are just loading the environment variables via load.env so that we could use the Gemini API key. Now that's pretty much it. Now what we are doing over here is probably very simple. We have talking about messages a lot. So there are 4 types of messages: system, human, AI and tool. Let's skip tool usage for this lecture. We've been talking about that a lot, so let's just forget it. Today we have 3 messages. So the system messages, you are a helpful assistant. Then the human messages explain the concept of AI, and a dummy AI message I have added. Okay. Now while true, that means an infinite loop. Input, enter your message. So user is going to enter its message as and when. Exit will occur. While loop, so whenever you write a while loop, always have a break condition. Then you are appending the human message, whatever is the user question you are appending to this list, you are printing the message, and then guys the same list would be passed to your LLM. It's going to make a response, and based on that it's gonna give you a response, and then we are printing it. See guys, I went to explain you the code line by line. Okay, so this is okay. Let's just print hi. Okay, so this is what most companies have, right? Nothing too major on it. Okay, so this time I think it's taking a little more time to respond probably. Okay, it must have responded. Okay, fine. Let's just ask joke on maths. Yep, so you're able to see, right? Let me just exit it. So it's like a simple rudimentary thing. This is a simple chatbot, and this doesn't have any agent capabilities. Okay, if you give your user an let's say an infinite conversation context and don't implement valid backend validations, probably you would run into a token limit error. Not you, as in the user is going to run into token limit error. And that is also not something very, like, that is also a very bad thing in terms of user experience. But even the bad thing is going to be that you would be occurring a lot of cost per API call. So the trend is good because guys, your messages would keep on stacking, right? The history pile would keep on increasing. So in every session, right, every session which the user is going to have, the cost is going to go up, and your tokens are going to go up, your latency is also going to go up. So tell me guys, is it nice or is it not nice? It's probably not nice, but for simple use cases, maybe you don't want to build a backend that's very robust. Maybe a good starting point is this, and over time you would realize that what you need to do. So I'm leaving this decision up to you, because even today guys, most systems are based on something like this, and it would take a lot of time to migrate those systems into modern solutions. But it's not that always modern solutions will win, but that's probably okay. So this is the rudimentary approach to show you. I just use a simple list, and that was my intention. Now moving to what we are going to do about agent memory. So guys, first of all, the first technique which you need to understand about agent memory is, it's a simple technique guys. It's known as filtering. Now what is filtering? Simple guys, instead of sending, so you'll make an LLM call, right? You'll make an LLM call. Instead of sending, let's say, the last 10 messages which the user and AI have interacted, so 10 messages would constitute 5 5. Okay, 5 would be user messages and 5 would be AI messages. So instead of like going 5 5 messages like this way, So five messages would make 10 in total. You're going to be just sending the last 5 messages. So you're filtering. Okay, so you're filtering your list, right? So let's say you have a list of 10 items. So usually we do like this, right? 9. So this is like basic list stuff, right? So it's going to be probably going forward, but you just need to implement something like this in your backend. Obviously, while at a session level, all these things will become a little more complicated on how do you want to do it. But I'm just giving you an idea, right? Instead of sending 10 messages, which are 5 from user, 5 to 5 from AI, let's just send 5 messages. So that would constitute maybe 3 from user, 2 from AI, or 2 from user, 3 from AI, something like this. So guys, this is very simple. Okay, I'll just show you Python code to do it. the the Python code to do it is simple. It's pretty much the same Python code. All we need is to set up some base messaging system from LangChain, and then guys, we just all obviously we would want always the system message to be included and last n messages to be included, right? So -2 is going to be the last up till the end of the string, right? So we are probably, you understand this thing better than me. So what are the last 2 messages? I just want to pretty much send that, right? You would understand this better than me. Okay, now we are good till over here. Now this is very simple, guys. Okay, there is no magic that's happening in filtering, but it's a technique that you should know. Okay, it's not something that's too magical in terms of coding. In coding wise, it's just for the time being, for this video, we are just doing simple Python uh list operations, right? That's pretty much it, nothing major. You just need to filter the list. Okay, filter the list so that it just takes the last 2 items or last n items, which is pretty much not something I'm covering because this is an agentic course. So if you want to understand more about lists and all, you could watch my Python playlist, or you could just study from ChatGPT or whatever you want to do, but that's probably okay. But this would help you a lot on token cost, right? Because in per API call, right, you won't be sending the entire history. Rather, this entire history would be cut down and only this portion of the history would be sent to here. So maybe you will lose some context, but you will save on cost. You will have better latency, and guys, in general, this is something that's recommended because even like we are conversing right now, I'm not talking in reference of vanilla chatbot that I talked about. I mean, in an ideal scenario, you can give me 1,000 examples where the first message is of very importance, right? That's why in the code, if you'll see, every time I'm sending the system messages, because usually you would want the system to behave the way you want it to behave, right? In code wise, this is not something you would be doing, right? I mean, obviously for POC level you can use this list and all, but obviously you will have a very different kind of a backend and some other stuff is going to be going on if you will be building a production ready chatbot. So but the main idea is this only, right? You would be somewhere using this thing only, that you would be filtering down stuff, and that probably depends on your choice of DB and how you would do that, those kind of stuff. But that's pretty much okay, guys. Okay, the main thing is you need to understand concepts, and obviously every organization has a different backend, different structure, everything is very different, so things change. But you got the sense, right? Coding wise, this is not difficult at all. It's just you need to figure out a way that you need to just filter your text, right? So we talked about vanilla chatbot. Now we have talked about filtering as well. So always remember in filtering, right? Always remember in filtering that you would might have 10 messages going on, but in the next subsequent LLM call, you would just send only 5 messages, which are usually last 5 messages. Obviously, right? Because the way we are conversing, right? So you're able to understand that what I said a minute back is more relevant what I said 10 minutes back. That's how humans also converse. Now guys, we are good with filtering. Now let's come to trimming. Now guys, trimming is also very simple in terms to understand. It's just that let's say this is your conversation that we have had and only take 1,000 characters. Okay, now characters is a vague word, so some people would like to count that as words. But guys, words is an even vague word. Some people would like to maybe call it as tokens. So in an ideal scenario, you should be going with a token level implementation that you're just sending the last 1,000 tokens. But obviously, for the point of discussion, you just understand what trimming is, right? You're just trimming. So you just need to trim, right? In based out of words, characters, or let's say guys anything. Tell me more. Tokens. So tokens is the main heart of it, right? So you just need to do it. For the time being, in terms of trimming, I'll show you a simple code, and this is guys very rudimentary code, right? This is not how you would do it, but it's an example. It's just a little bit of a raw vanilla code which I'm showing you based on simple Python list, right? Okay, no scalable chatbot that would be you build, like that would be serving a lot of people would be using list, and anyhow if it's serving less people, then maybe you wouldn't want to do so much of stuff. And even a simple filtering technique, right? Just send the last three messages. That's pretty much going to work. But I'm just telling you because this is a full agentic code, so you might someday implement trimming as well. So I have just written a simple Python function. Let's just go through it again line by line, like we did it for our previous codes. So let's just go for it line by line. So let's just go line by line. So even guys, see, in the times of AI also I teach you code line by line, and still you guys don't subscribe. Just kidding, it's fine. So guys, you can just understand last n words. So what are the total number of words and what are the trimmed messages? A simple list. Fine. So for message in reverse messaging, so first thing what we are doing is we are trying to reverse everything because we want to have a look at the back of the message first, right? Then we are trying to just have a look at the fact that if total words is greater than 100, then only you would like split, right? Until you haven't reached that token limit, you would keep on having a natural conversation. If it is that, all I am doing is that how many words you need to take from the back, and if the words that you need to take from the back are greater than zero, just guys a simple like breaking down those words into like sub tasks, right? Like we do it for Python level things, right? It is very simple guys. I'll explain you. You can understand this code. This is very simple. It's just you've been doing this a lot of times. So in your previous once you were learning Python, you would have learned these things, right? That let's say you have this kind of a thing, right? A B C, and then you're just doing dot split on comma. So you have comma, right? So you would be doing comma, then you would have A, B and C, and then you would count those stuff and then maybe take the last 100 or whatever. So that is pretty much okay, right? Code is secondary part of this like application, but you understand this function in simple terms is just going to take the string, it's going to reverse our list that we have, it's going to break it into multiple words and take it the last n words, which for the time being you can consider simple as 100 only. Now this is the concept of trimming guys. Okay, if you would see the example, right? If you would see this chat which I had with the system message is always going to be sent. Now guys, this is very important. Never miss this. Okay, don't tell that I didn't explicitly point out. System message needs to be always sent, right? So that the model is more aligned towards the way you respond, right? Even sometimes whenever I'm having a chat with Claude, I realize that in the starting of it, it gives me great responses based on my first message. But sometimes guys, as I go deep into the conversation, it kind of loses a track because they must be also implementing something so that the token limits are balanced and all those kind of things. So you're able to understand this. Okay, but guys, system message is very important because this is going to help you align the model, okay, for safety purpose, and in general also this is usually always recommended. Okay, so some people can say, sir, we can just do a simple string over here by this UR. So all those kind of things are also possible in Python, but it's good, right? If you're using a framework or something, you just use the simple message class, that's okay. But you just need to understand one thing, that you would be just trimming stuff from the back, right? So see, the system message is always sent. You are a helpful assistant. Now see, AI messages, concepts to model and physical phenomena. whatever I had the previous conversation is lost, right? But guys, you need to take a call whether you need to balance context and cost. It's up to you. I can't give you an answer today. Now the third one is summary, and this is your homework, guys. Summary is very essential. Sometimes implementing summary is relatively simpler. Okay, so and like summary is nice also. It's kind of relatively simpler, so it's not very difficult. And this is your homework. You need to write some vanilla Python code for summary. I think you can do it. So first of all, you'll be having a conversation. Okay, you'll be having a conversation, as in when let's say you've exchanged 5 messages. Now let's assume out of these 5 messages, 2 are from AI, 3 are from you. So what you would do is you would summarize this conversation. Okay, conversation. And now this summary would be one message. So your 5 messages would get condensed into one message, which is your summary. And then guys, in simple terms, you can use the summary of the conversation and the current user question, and what you will use, guys, tell me. Every time, guys, system message. So whenever you're having a conversation, you would be using three things. One is summary from, let's say, the past 10 messages, then is the current user question, and then the system message. So this is your homework. You need to do it, guys. Please uh, push this code into comments section of GitHub, and I'll be individually reviewing each one of your code. So this is pretty much it. Now let's just try to summarize what we have talked about till now, which is very important, guys. Python implementation is very rudimentary. This is not how on like an chatbot, if you're building for an org, you would be doing something like this, but these ideas would be useful because every backend structure is different. So once you understand this, you can probably crack it. So in terms of conversations, very important idea of agentic memory is that the model needs to be smart. It needs to understand me better. It needs to have an idea, right? That it should improve with every conversation. It's not like that. Otherwise, what is the difference between a chatbot and agent, right? If it is not improving with every conversation, it's pretty much same. So the first technique which I talked about was filtering. This is, guys, something which is most commonly used. It is very effective. It comes down from an idea that when you and me are talking, even I don't remember what was the first thing that I said. So filtering is something whenever you make an LLM call, only send the last 5 messages. But guys, always remember, like then this, like in Python you can do with something like this, but that is probably okay. I'm less worried about that. What I'm worried about is please send the system message as well. Don't forget the system message as well. Now this is filtering. So, and why do we need to do this? So that our token costs are balanced. Okay, our latency is reduced, and guys, very importantly, token cost and token usage, everything is balanced. If we'll do this, it's a most simple technique. And usually guys, I'll tell you, as I was telling you, that somehow you need to figure out what DB kind of a structure you are using it. But usually, guys, in Python kind of a thing, you need to figure out to use it with some kind of data structure and which is native to Python, right? So if your backend is in Python, then I don't think there's a problem in using lists. I think a lot of frameworks which are being built on Python are also built on lists as well. So for most cases, you can use lists only. It's fine. Now the second technique which I was talking you about is trimming. So what is trimming? Let's say we had a big chat, and now in whenever the LLM is going to see this, it's just gonna cut it down, let's say, to the last 1,000 words, last 2,000 words. And often, guys, as I said, right, how do you define words? Because words to us is something else, and words to an LLM is something else. That's tokens. So in an ideal setting, you would need to implement it at token level, which is I would say slightly not difficult, but you need to like use tick token from Python if you'll be coding it up from scratch. And obviously uh, the playlist is now like we've already finished 4 to 5 lectures on LangGraph, so we would be doing the entire thing with LangGraph, so that it's good for you to see the abstract representation, which is going to reduce your coding efforts. But that's okay, but you need to understand it. Again guys, all benefits: tokens, usage is reduced, token cost is reduced, latency is reduced, so we are all win. Now the fourth technique was summary, or the third technique, whatever you're considering. The summary is very important. So guys, very simple, right? In every 10 messages, after every 10 messages, make sure that whatever 10 messages which are exchanged by AI in the system, right? 5 you just condense that into one messages with the summary. And this is your homework guys, you need to do this. You need to write some kind of vanilla code so that you can understand it. Obviously, right, as and when projects would be done, you would be clear with these things, but you need to understand this summary feature, and it's probably a cool feature, right? And thus guys, if you will implement any one of those things and you will design your backend database in a better way, what will happen guys, like I just showed you this thing, how are like they are able to know in a fresh session, tell me about myself, because they've designed it in a way. And this is very like a Python thing to do. This has nothing to do with generative AI. Yes, they understand that okay, agents require a little bit of more personalization, they need to understand you better, so let's just throw it. So this is how you need to do guys. So in background they must be making some sort of profile summary, right? This is not very difficult feature, but it requires some sort of creativity. Only thing you need to understand is why we are doing this, why I'm making this lecture, because guys, I want my agents to know me in and out. If your agents don't know you in and out, I mean, what is the fun of them talking about agents as well, right? They are going to be recommending me stuff which is probably run by some sort of custom, let's say ML algorithm, or how bad we all have seen, right? Similarity based algorithms. Like sometimes people say, why I have been showing this ad? This is not something what I do. All these kind of things we have seen, right, in India. So just make sure that you have some sort of a memory store. Okay, this memory store is very important. That's why guys, effective use of vector DBs is very important. Every conversation, everything needs to be stored, and you need to manage vector DB a lot. I think managing vector DB is going to be such a crucial thing in future, because everything is going to be boiling down to text, and anyone who understands vector DB is going to be a valuable asset, even if you have so many agents, right? Because you need to understand that how would you summarize, how you would make sure that every conversation is summarized. Okay, how do you want to implement uh, a trimming, like which tokenization? There are multiple type of tokenizations even available. uh, okay, if you're going to be using filtering, then it's relatively simpler, because you just need to delete the past 5 messages, but you understand, right? And guys, this is just the starting of agentic memory. There would be more stuff on it. We'll be doing a lot of stuff with LangGraph and other things as well. But guys, build something that uses long memory. And guys, right now, like if maybe you would have all the money and infrastructure, build something which might even have infinite memory, right? My whole life is nothing in, actually it is just a database. It's pretty much it. Now I don't want to go into the discussion whether it's a vector database, SQL, MongoDB, Cassandra, Postgres, all that is crap. That is not what I'm trying to tell. Our entire life is a database. Once you have access to infinite memory, any system, right? Even forget agents and all, even GPT 3.5 will be a great help to you, because it's going to help you evaluate stuff based on everything which it has access to. which has happened in your lifetime. So guys, this was a lecture on agentic memory. Thank you, and please subscribe to my YouTube channel, guys. Have a great day.